So today I wanted to talk about the relational model. This is the underlying model for SQL databases, and it's interesting because it's such a simple model and seems to have such a wide variety of applications. Also, because it's a formal model, you can do interesting mathematical reasoning about it as well. So I think I mentioned in another video that the relational model is one of the really nice things that has happened in computer science, where we've got this data model that maps very naturally onto the underlying storage model and gives us SQL databases that are closely related to the relational model with all of the properties that that gives us. Okay, so first thing, we're dealing with data. And in the relational model, basically the data is all expressed as a set of tuples. So every chunk of data ends up in a tuple, and we have groupings of tuples that form relations. All right, so what does a tuple look like? Well, it's basically just a collection of values where each of the values is drawn from some underlying domain. So in maths we often write tuples as something like that. So that's a triple, 3 fields, which we can call, if we want, x, y, z. We haven't specified anything about the types yet. If we wanted to write an instance of one of these tuples, let's assume that the first value is an integer, second value is a character, and the third value is an integer. So that's a specific instance of a tuple that matches this pattern, and if we really want to be specific, tuples are instances of values drawn from a data type, which is a cross product of domains. So if I wanted to express the type of that tuple, I could say it's a triple which contains a single int, an int char followed by another int. So if I've got a whole bunch of tuples that look like that, or that are drawn from the same underlying domain, and I'll put them together, I end up with a relation. Now, relation, the name suggests it's some kind of relationship. Technically, a relation is just a set of tuples, all from the same underlying domain. Notionally, there's some kind of connection between all of those tuples and between the values within the tuple generally. So if you're talking about something like a student table or a student relation, you may have student ID as the first component. Second component might be the student's name. Third component might be the program that they're studying. So there's clearly some kind of relationship between all those things. This student ID identifies that particular student. So basically a relation is just a set of tuples. We'll often draw relations as tables, and basically that's what the SQL model is all about. It's a particular implementation of the relational model. So let's imagine that we've got a table over here with 3 columns. Each column represents one of the components of the tuple. Let's give a name to that relation. We can call it R. So the tuple that I've just drawn over there could be rendered in that table as 1T3. I suppose I should put an underline to indicate that's a bunch of headings representing the names of the components or the attributes, and this, each row, is a particular tuple. So I can have another tuple like that. I can have another tuple like this. And I could have another tuple like this. Okay, so there we got 4 tuples comprising a relation called R. Each of the tuples is a triple of int char int values. So that's pretty much all there is to the relational operation data-wise. Of course, and I'll talk about this in another video, we need operations on these types of values. And the operations in the strict relational model, they always map a relation or a combination of relations to another relation. So we could have an operation that maps one collection of tuples from one relation to collection of tuples of the same type. If we want to change the type of the tuples on the way through, then we might have an operation like that. If we want to combine tables in some way, then we might have an operation that combines a relation of type R, if you like, or a relation called R with a particular type, and a relation called S with potentially a different type, and gives yet another relation which may have a totally different type. In terms of the relational algebra operations, this would correspond to a selection operation. So a selection operation basically just gives you a subset of tuples from the original relation. So all of the tuples that end up in the final result have exactly the same structure as the tuples in the original result. You just get less of them. Mapping from a relation to a relation of a different type could be a way of talking about projection. So maybe we're taking a subset of the tuples. So we've got the tuples here, int char int. Maybe the tuples in S simply have the first two fields from that. They're an int followed by a char. So that's what a projection operation would give us. And finally, the other very common operation for relational data is join, where we take tuples from two tables or two relations and combine interesting or related tuples and produce a table with all the combinations of, if you like, matching tuples from those two tables. So that's pretty much all there is to the relational model. Data is always done as a set of tuples. A set of tuples of the same type forms a relation, and a tuple is defined by the types of the values in the tuple. That's the tuple type, and a particular tuple is defined by giving a set of values drawn from those types. So that's the relational model.